Algebraic functions, the quadratic. So here we have f of x is equal to x squared minus 10x plus 30. The first thing I want you guys to do is to determine the axis of symmetry. The axis of symmetry of a parabola is a vertical line that divides the parabola into two congruent halves. It always passes through the vertex of the parabola. Later, I will show you the graph. This formula comes in the form of ax squared plus bx plus c, the formula of the quadratic. So in this case, b is negative 10 and a is 1. Let's plug in the values. So my axis of symmetry is 5. The axis of symmetry will be the line to split my graph, so my vertex has to be on this line. So now let's have a graph. Since I have my axis of symmetry, which is 5, this will split my graph. So this is 5x Before that, how do we determine the graph if it opens up or opens down? First, we need to determine what our A is. Our A in the equation is equal to 1. There's a rule that if A is greater than 0, the graph opens up. So this means that the parabola has a minimum point. Right now, I need to determine some points by using or making table of values. To determine my f of x value, plug it in so you can say, let's use my axis of symmetry. This is from my equation, f of x. So 5 times 5, 25. So my f of x is 5. My axis of symmetry is 5, right? And my f of x is also 5. Now, I need the closest number of my axis of symmetry to get the other values of f of x. So just like how to determine my f of x, to get the other f of x values, refer on how I solved earlier. So we have 9, 6, 6, and 9. Since I have my table of values, complete table of values, let's now plot. 5, 5. This is the vertex. 4, 6, 4, and 6, 6, 6, 6, and 6, 7 and 9, and 3 and 9. So this is how we graph the quadratic functions.
Lolo, wala akong regalo.
Don't worry, Apo.
Shopee!
Sa Shopee, Pasko na bumili. Sa Shopee, sa Shopee, free shipping, Pasko na sa Shopee.
Shopee 1212. Shop na!
Akin ka na lang, akin ka na lang, ang dinadasal sa araw-araw. Akin ka na lang, akin ka na lang, at maghihintay hanggang akin ka na.
So hello everyone, I am Elaine Benipayo and I'm gonna discuss about logarithmic function. So what is log? I'm gonna explain log through a short just chant that we'll probably not forget about what is log. So the chant goes like this. Log is an exponent, log is an exponent, log is an exponent. So log is an exponent. So log is which is equivalent to equals an exponent. Wait, hindi ko balance mo. So let's see it in an action. So for example, log base 2 of 8 is equals to. So what that? So it is the exact same statement as 2 to the question mark is equals to 8. This statement and this statement are identical statements. They are just two different ways in explaining the exact same thing. So what would it be? I think it would be the question mark is equals to 3, in which if we raise 2 to the 3, we will get 8. So for the another example, if I say y is equals to log base b of x, so what does that mean? So it is the exact same thing as, let's chat together, log. So here we have another example and we're gonna graph it later. Next, we're gonna convert this into a new version so that it would be easy for us to solve. So the converted version is x is equals to 2 raised to the power of f of x. So let's make a table now. And we're gonna assign values for x. What if I would put 1 in x? What will be the power to be raised? Let's make a table. So if I'm gonna put 1 here, what would be the value to be raised in order for us to get 1? So the answer is 0. Next, if I put 2, the number to be raised to 2 is 1 because 2 raised to 1 is 2. Next is 4. The number to be raised to 2 is 2 because 2 raised to 2 is equals to 4. Next, so we're gonna try small values. If I put here 1/2, we're gonna raise it to -1 in order for us to get 1/2. Next is 1/4. So the answer is -2. And lastly, 1/8. 2 raised to -3 is equals to 1/8. So we're gonna plot the x and y values, 1 and 0. Next, 2 and 1. Next is 4 and 2. Next, 1/2 and negative 1. Next, 1/4 and negative 2. And lastly, 1/8 and negative 3. So we have finished plotting the different values, and next we're gonna connect the dots. So this is the graph of the given logarithmic function f of x is equals to log base 2 of x.
This one's for Earth. This one is for Earth.
Bingo. Boom. Love that one. Felt it.
Yeah, felt good. Hey Siri, read my schedule.
You have 25 appointments at 7:15,
Oh, look.
7:20,
You're on the telly.
With so many projects in the works, it seems like Dwayne Johnson can't possibly take on any more.
Well, that sounds like a challenge.
Hey, Dwayne, where we going, buddy?
Dwayne, buddy.
Hey Siri, show me my life goals list.
I found 10 reminders.
Thank you very much. Hey Siri, give me a Lyft ride to LAX.
Lyft can get you a lift in 60 seconds.
Mind if I drive? I know a shortcut.
You're,
Yeah. Hey Siri, what's the temperature in Rome today?
The high temperature for today in Rome will be 80 degrees, and the low will be 59 degrees.
So, do I pay you?
It's on me. This is your new captain speaking. Looks like we have nice weather coming up for Rome, Italy, so sit back, relax.
This plane's going to Akron.
This flight's going to Rome. Hey Siri, read me my last email.
At 9:30 a.m., Visvin sent you an email about Mr. Nakamura can discuss your fashion line.
I'm out. Hey Siri, show me photos of my fashion line. Hiroka-san, what do you think?
It doesn't really matter what I think. What do you think?
Oh, I think it's showtime. Everything in life is made up of 4 elements. Wind, fire, water, rock. Hey Siri, text Chef Ludo. I want to cook. Hey Siri, how many ounces in a centiliter?
1 centiliter is 0.34 fluid ounces.
Je sens ce que l'Europe nous mijote.
Messi, give me some. Hey Siri, play my practice playlist.
Hey, Siri, FaceTime, Dwayne.
Making a FaceTime call to Dwayne.
Okay, when are you getting back to set? Everybody's freaking out here, man. We still got the last shot.
Don't worry, I'll be there, okay?
Okay, well, I'm gonna go get fired.
Bye.
Bye.
Hey Siri, take a selfie. Hope it don't cause an eclipse.
I promise he'll be here. He's very punctual.
Okay,
Just
mate.
roll or
All right,
do whatever
if you
you
say
do.
so. All right, let's roll film, please.
This one's for Earth.
Cut!
All right, that felt good.
DJ, that was amazing, man.
Are you okay? Of course you're okay.
Cock-a-doodle-doo, Johnson.
You just seen his crash.
Cock-a-doodle-doo.
So glad you're all right, man. I'm so glad you're back. We got a lot to do.
Yeah, we do have a lot to do. Hey Siri, create a new list.
What should I call this list?
Life goals, the sequel.
No,
Okay,
Normally
I've
I
created
like
it.
sequels, but I think right now we need to push off on that and just keep you open for other projects.
Hey Siri, you're the best.
Thanks, Mr. Big, bald, and beautiful.
I love you too.
My desk is on the 7th floor. If you need anything, you can call me. Make sure to keep your ID with you because you're going to need to badge in every time you re-enter. Cafeteria is on the 4th floor, and we generally take lunch about 12:30.
This is where I'm sitting?
For now, yeah. With the big move coming up, it's kind of crazy around here. I promise it's only temporary.
All right, thank you.
Come on! We need Airbnb! This is not an Airbnb! Where are we, man? I don't know, man! I don't even know what city we're in! Look out!
World leaders are declaring a global state of emergency until the app situation can be resolved.
Selfies! Hey, buddy! Selfies! Selfies!
Apocalypse is nigh! Apocalypse is nigh!
Okay, who wants to go first?
iTunes! Get you iTunes!
Do you think we should have gone with the puppy face?
I just ate this whole pizza by myself! Hashtag too delicious to share! Hashtag pizza emoji!
Farmville 2 right here, y'all!
Hashtag Instafood!
Brian, looking for Brian?
Hashtag does anybody want a slice?
Guys, I am Clear Constantino, and I'm here to discuss about the sketching of transcendental function. Now let's talk about trigonometric function, which is part of the transcendental function. Before that, let's talk first about the angles. Angles is determined to rotating by a ray of its endpoint, and the starting position of a ray is initial side of an angle. Initial side of an angle is look like this is initial side of an angle. After rotation is the terminal side. It might be counterclockwise that gives us positive angles, clockwise that gives us negative angles. Now trigonometric function. It is usage, for instance, in navigation, engineering, and physics. For common use in elementary physics, it revolving in vector into Cartesian coordination. For modern usage, we are familiar with the sixth trigonometric function, which is the sine, the cosine, the tangent and the cotangent, secant and the cosecant. And the most familiar trigonometric function is the sine, cosine, tangent, which is the representation of an acute angle of a right triangle. We are also familiar with the SOHCAHTOA and the SOHCAHTOA, which is used for the formula of the sixth trigonometric function. For example, a surveyor standing at the building that has 115 feet from the base of the building. The surveyor measures the angle of elevation of the top of the building as 78.3 degrees. How tall is the building? Now we have tan 78.6 degree is equals to opposite over adjacent. Instead of using opposite over adjacent, we are using y over x, which is our y is equals to height, then x is equals to 115 feet. Now we have y is equals to x tan 78.6 degree, which is our x is equals to 115 feet times the tan 78.6, which is our y is equals to 555 feet. So now our height of this building is 555 feet. Now I'll show you some of the graph of trigonometric function. We have figure A and figure B. I want you to find the equation of these waves given our A and B graph. Now for our figure A, let's say that our range for this graph is 2 to 8. And this point have 2 pi and this have pi. Let's identify the needed values for finding the equation for this graph. For our figure A, let's say that our range for this has 2 to 8 and this point has 2 pi, here as pi. Our generic equation is y is equals to a sine times bx plus c plus d. First, we are looking for the value of our c is equals to 0. How come? As you notice to our graph, it was started at the origin, which is x is equals to 0. So our c is equals to 0. For d, d is the vertical shift of average of number 2 to 8. So 2 plus 8 over 2 is equals to 5. 5 is the midpoint between 2 and 8. Now we are looking for the value for our b. We have period 2 pi, which is period is equals to 2 pi over b. Our period has 2 pi is equals to 2 pi over b. So basically, our b is equals to 1. For amplitude, amplitude is the distance of these two number, which is 8 minus 5 is equals to 3. Now we have our equation for this graph, which is y is equals to 3 sine x plus 5. 3 for the amplitude. The x is from b is equals to 1 times x, so x. So this is our equation. And now we were going to find the equation of this graph, figure B. We have 1 to 9, and we have period of pi, and here have a pi over 2. Our generic formation is a cos times bx plus c plus d. How would we know that if it is cosine or sine? Cosine, it is started from the bottom or from the top. From sine, started from the middle. So this is a cos bx plus c plus d. First, we will going to find the value for c, which is the origin 0. For our b, which is we all know that t is equals to 2 pi over b, and our period here is pi. So pi is equals to 2 pi over b. So basically our b is equals to 2. How come? This going to work, multiply, cross multiply, then cancel the pi. So the b is equals to 2. Something like this. Cross multiply. B pi is equals to 2 pi. Cancel. B is equals to 2 pi. For d, the distance of this 1 plus 9 over 2 is equals to 5. So our midpoint is 5. Our amplitude is the distance of these two numbers, which is 9 minus 5 is equals to 4. This is now our amplitude. Now we have our equation y is equals to negative 4 cosine 2x plus 5. It is negative because our graph started at the bottom rather than on the top. So we got the negative 4x cosine 2x plus 5. We have a problem for a pendulum swing back and forth at 10 times in 8 seconds. It swings through a total horizontal distance of 40 cm. We will sketch a graph for a 2 cycle of motion beginning with the pendulum at the end of its swing. And we will write a sine and cosine function. We have a pendulum diagram of a swing. It has back and forth with a distance of 40 cm. Now let's have our sketch. This x-axis is our time, which is using of seconds. Our y-axis has our distance, which is our cm. Assuming that our x-axis or our time is our middle distance, and according to the problem, we have a total horizontal distance of 40 cm. And in order to have a 40 cm, we will going to have 420 and negative 20. As I said, as we start at 20, as our pendulum swing, we will go back to 20. So in order for us to go here, we will have to go down at these points here. So I will going this twice because as our A need 2 cycle of motion beginning with the pendulum at the end of its swing. So another point here. For our another cycle, we go here. It's monthly. Then it's back to 20. Now this is our A. Now let's write for our sine and cosine function. In sine function, I'll start my sine function at this point over here. As I have discussed that sine starts at the middle. So this point starts at the middle. In order for us to have our equation for sine and cosine, we will find the k value and the amplitude. A is equals to 20 plus 20 over 2 is equals 20. P, or our period, is here 4 over 5 seconds. P, or period, is equals to 2 pi over k, which is to substitute k must be equal to 5 pi over 2. For our equation for sine, d is equals to 20 sine 5 pi over 2 x minus 3 over 5. For our cosine, d is equals to 20 cosine 5 pi over 2x. As you can see, it is positive because our point starts at the top, which is positive. Going back to our problem asks for a sketch. So this is A. Our sketch for the problem. And this is our B for the function of sine and cosine.